Welcome to our Certified Fire Protection Specialist Exam Preparation course. And again, I'm your colleague, Mr. Marvin. Now, our topic is about Module 9, Special Equipment Process and Facilities. Okay, and I assume that you already had the materials with you, which I sent to your email and to our WhatsApp group. Okay, however, if you're not getting any email from my side, please do let me know. Okay, let's start. So again, welcome to Special Equipment, Process, and Facilities. In this module, we will review the fire prevention and control of electronic equipment, refrigeration system, and semiconductor manufacturing. We'll also learn to paraphrase the fire protection best practice. Hold on. The best practice, the basic operating principle of a refrigeration system, and hazard control safeguards in semiconductor manufacturing. And we will hear something from Mr. Guy, Senior Director of Engineering at NFPA, which will discuss some of the precaution related to hot work at building sites. And Mr. Bruce, also an NFPA Certified Fire Protection Specialist, will share risk engineering and loss prevention insights related to photovoltaic and energy storage system. If you complete this module, you will be able to recall whatever primary topics in Fire Protection Handbook, Section 8 and 9, describe the precautions of hot work, determine the spacing requirement, given a chemical or type of equipment, used to produce the chemical, and use a table to determine whether or not a vehicle is approved for operation in a class 1 to 3 location. You should also be able to determine suppression system best suited for IT fire prevention and safety. Use refrigerant safety group classifications to determine level of flammability and toxicity. Describe the three types of refrigeration system: mechanical, absorption, and steam jet ejector, and their hazard. And lastly, determine the best placement of a refrigeration system in a given environment. And lastly, again, assess the hazard level in a given refrigerant and environmental condition. Identify fire and health hazard associated with semiconductor manufacturing. Describe energy storage system, ESS, and solar system application and types. Outline steps to take during fire incident. Involves ESS and solar system. In this module, we reference some of the contents found in your Fire Protection Handbook Section 8 and 9. Majority in Section 9, okay? Section 8 will be addressed related to chemical processing and materials handling equipment, as well as protecting the electronic and IT equipment and refrigeration system. On the other hand, the Section 9 has total of 17 chapters covering fire protection of a variety of process in a highly specialized facility. So those are what we will all discuss, okay? Almost everything of Section 9. Let us watch a video of video transcript of America, the Rider, Louisiana Pulp and Paper Mill. Okay.
February 8, 2017. The Packaging Corporation of America's DeRidder, Louisiana Pulp and Paper Mill. An explosion occurred during hot work activities, killing 3 contract workers and injuring 7 others. The DeRidder mill produces container board that is used in products such as boxes and cardboard displays. The container board is made from pulp produced at the facility. During the process of creating pulp, vapors are generated. These vapors, which contain water, turpentine, and various sulfur compounds, are collected and separated. To separate the vapors, they first enter a turpentine stripping column. There, most of the turpentine is removed and sent to a condenser. The remaining vapors in the stripper condense to a liquid containing mostly water, but also residual amounts of sulfur compounds and turpentine. This liquid is known as foul condensate. The foul condensate is sent from the stripping column to an approximately 100,000 gallon capacity atmospheric storage tank used to store the liquid at or close to ambient pressure. The foul condensate tank is primarily used to regulate the flow of liquid between the turpentine stripping column upstream and a downstream unit that removes the remaining sulfur components from the water. During the February 8th incident, the mill was undergoing its annual shutdown. The shutdown required mill employees and contract workers to perform maintenance, inspection, and upgrade tasks throughout the facility. One of these tasks was the repair of water piping, located above and connected to the foul condensate tank that had shifted and cracked months earlier. The repair required welding on the piping, commonly referred to as hot work. In preparation for the hot work, valves were closed leading into and out of the foul condensate tank, while 10 feet of liquid remained inside. The liquid was left within the tank partially because there were no plans to work directly on the tank during the outage. The company also assumed that the tank contained mostly water, was sealed off from the atmosphere, and did not pose a safety risk. These assumptions were, however, incorrect. Residual turpentine, normally present in foul condensate, collected on the top of the liquid in the tank due to its density. The foul condensate tank was designed so that by changing the height of the liquid level inside the tank, the residual turpentine would be skimmed off and sent to a turpentine recovery system. But in the months leading up to the incident, the turpentine was not removed because there was confusion as to who at the mill was responsible for operation of the foul condensate tank. Due to this confusion, a valve designed to direct skimmed turpentine to the mill's turpentine recovery system remained closed for months. As a result, leading up to the incident, more flammable turpentine was present in the foul condensate tank than anyone expected. In addition, there are normally vapors inside the foul condensate tank in the space above the liquid. Although those vapors can become flammable, they are supposed to be kept at a concentration that is too rich to burn. But due to the non-routine conditions experienced during the annual shutdown, the contents of the tank likely cooled, creating low pressure within the tank. This most likely triggered a relief valve on the tank's roof to add more air to avoid damaging the tank from the vacuum created by low pressure. The vacuum relief valve was likely one of the few potential sources that allowed enough air into the tank to create an explosive atmosphere. In preparation for the hot work, the water piping was isolated from the foul condensate tank and the rest of the process by closed valves, and the piping was separated physically from the tank. Around 8 a.m. on February 8th, a mill employee used a gas detector to check for a flammable atmosphere in and around the water piping, and found none. As a result, the company issued a hot work permit for the welding work. But even though a flammable atmosphere was not present outside the tank, there was a flammable atmosphere inside the tank. Without knowing that the tank posed a serious hazard, 3 contract workers began welding on the water piping located above it. The CSB was unable to determine an exact ignition source, but it is likely that sparks or molten slag produced from the hot work landed on or near the foul condensate tank, heating up the tank wall or otherwise igniting the contents inside. Or it is possible that the hot work was complete, but as the tools were lowered, a welding torch fell and created an electric arc on the tank or its vent piping. Regardless, the CSB determined that hot work activities likely ignited the flammable vapors and liquid turpentine inside the foul condensate tank. At 11:05 a.m., there was a large explosion. The tank separated from its base and launched up and over a 6-story structure, landing approximately 375 feet away. 3 people were killed and 7 were injured. All were contract employees working near the foul condensate tank.
Click next to hear Guy Colonna.
Okay. Let us hear Mr. Guy Colonna, a professional engineer and a senior director of NFPA, present his observation of what you need to witness as a guidance for hot work best practices. Okay.
Having watched this video, one of the things that we see highlighted from this video in terms of hot work best practices is that the company, in preparation for the hot work that they needed to be have accomplished that day, involved atmospheric hazards. And so they did atmospheric monitoring in the area as part of their preparation and their documentation for issuing the permit. One aspect with respect to atmospheric hazards is that they are changeable. There is potential that hazards that the concentrations don't exist throughout the course of the work, and so it is better practice perhaps to consider continuous monitoring of atmospheric hazards. So as we look further in terms of the investigation and the information that the Chemical Safety Board has illustrated through this video, one of the other aspects that is important to not lose sight of, and that is the aspect of, as you're planning your hot work, it is important that you understand all the areas where sparks and slag can travel. So if you have high winds, they can blow greater distances horizontally. But in this instance, and any time you are doing hot work on an elevated platform, it is important to understand where the sparks and slag can be taken by gravity, because they're going to fall down. And in this instance, as illustrated in the video, the work was above that tank where the likely gases and vapors were being emitted from in terms of evaporating and possibly bringing the ignition source from the falling sparks and slag into the area where the gases and vapors were present. So in terms of the hot work activities, what this video illustrates are some practices that are sound practices with respect to preparation leading up to the permit process. But what's important and to take away from the incident is how conditions can change. And that's illustrated very clearly in terms of the atmospheric monitoring, and why I suggested that you might consider continuous monitoring anytime you're dealing with atmospheric hazards. And then the second aspect is, as part of identifying where your fuel sources are relevant to or relative to where your ignition sources are going to be, anytime you're doing work on an elevated platform, you need to make sure that you have guarded the sparks and slag from reaching a point where you might have fuel sources. And that those two items are coupled with all of the best practices in terms of hot work. When you're looking at trying to make sure that hot work isn't the ignition source for a fire, there are several things that you can do. One is consider alternatives and just don't do hot work. But if you have to do hot work, you have 3 alternatives. One of them is to move your hot work to an area where you don't have any hazards. The second is to ensure by distance that you have moved those fuel sources a safe distance away. And that's what gets challenging with respect to any time you're doing hot work on an elevated platform. And then the last option is to shield or protect the hot work residues from potential fuel sources. And in this instance, that might have been something that could have been done by capturing the sparks and slag where they were falling below that elevated area, and then they would not have fallen in the vicinity of the tank below.
And in this module, we will examine a variety of specialty equipment, process, and facility. Let us discuss the chemical processing equipment. So let's imagine that there is a large oil plant in constructing an on-site fire station. The question is, how far from the atmospheric storage tank should the fire station be located? When considering the loss prevention and the processing facility, the most important feature is the distance between the site and the populated area. The distance tends to be to reduce the casualties.
Yeah. Fire station should be including fire drill tower also.
Sorry?
Fire station, including fire drill tower.
Drill?
Drill tower for practice for all.
The drilling, of course, based on your emergency response plans, you
Yes.
do the mock or drilling exercise.
Correct?
Yep. Imagine if a toxic release were to occur, the distance of facility can lessen the effect of gas concentration on the public and will allow time for evacuation of neighboring population. If the hazard is a fire or explosion, the distance will lessen the intensity of the impact of heat or reduce blast overpressure effects on the population. So one frequently overlooked consideration for plant setting is the function of government and the city planning near chemical processing plants. There have been numerous cases where industrial plants were initially located in remote area, leaving a safe separation from the population. Then the population growth required an increase in homes and other business near the industrial plant. In order to avoid this, a company must acquire sufficient land area surrounding the operation that will be population free. Sometimes the acquisition of additional property is a matter of economics for operating company. This is why an action on the part of the government is required to maintain a population-free area through zoning restriction. A plant that may release toxic gas or has the potential for major fire or explosion must be designed to high standard of safety and loss prevention. And according to the section 8 of your chapter 2 of your fire protection handbook, discuss the block approach as one method for plant spacing. So what is the block approach? The block approach relies on the assumption that fire or unignited spills of flammable material can be attacked from all directions if they occur on individual blocks of land surrounded by access road. If such access were possible, it will provide freedom to take advantage of both wind direction and shelter afforded by peripheral structure. Inter-unit location. In addition to considering the distance between the plant sites and populated area, which we want to keep it far as safe as it is important to keep in mind that there are also inter-unit or intra-unit spacing requirements for oil and chemical plants. Let's return to our original question about the placement of fire station on a large oil plant site, and we will use figure 8.2.1 for that. inter-unit spacing requirements according to your fire protection handbook. Now, we will use the table. How far from the atmospheric storage tanks would the fire station need to be located? Okay, so actually, we will go to figure, if you print it out, what is that? 8.2.1, no? Okay, so now the question is atmospheric storage tanks and fire station. Fire station and atmospheric storage tank here. So this is the required distance, 350 feet, no? Or 106.75 meter. So very simple. Just this is the inter-unit spacing between the fire station and the atmospheric storage tank. So this is the enlarged view. Another, what is the safe spatial distance required between emergency control, okay, and high hazard reactor? So the same thing, emergency control, high hazard reactor. I think 8.2. 8.2.2 and then high hazard reactor. So here you will get 100. Okay. So it is 100 feet. No? 8.2.2. So this is how it looks like. Okay. As chemical plant process larger quantities of materials, it becomes impractical to provide ever-increasing separation of process unit. Where the toxic, flammable, reactive, or otherwise hazardous materials might be spilled, there are 6 logical steps to follow. Okay? So we can use our general knowledge to place the steps in the correct order. But you can go to page 8-21 of your fire protection handbook. Here. This is the other means of control. So this is this one. How we can make an annotation here. View. Here. Okay. I have to make it a different color. Okay. So we can answer the slides. No? Minimize possibility of uncontrolled spill. That's the 6 steps. Again, to contain hazardous spill. Then minimize the size of a possible spill. Minimize the spread of possible spill. Prepare alarm and evacuation plan if toxic release can occur. Control source of ignition and provide protection for exposed property if ignition does occur. Other means of loss control, the use of water spray, either fixed sprinkler or water spray system with monitor nozzle is an appropriate method to control water-soluble vapor from the air. And this strategy also works for liquid that is expected to be released as a mist into the atmosphere, but it requires a large water supply at high pressure to be immediately available for emergency response. Tapping firewater system is typically the way to address this need because they are usually available at the required pressure and volume. Water is not only used for vapor mitigation or minimizing, but the exposure protection as well. The automatic fire control and extinguishing system are the first line of defense against fire and explosion. And this system require a reliable water supply that can provide the need for pressure, flow, and duration. Let us again discuss some question. Chemical plant service building needs to be at what distance from intermediate hazard process unit. So again, if we will go to the same table,
61 meter.
8.2.1, okay, we will get the right answer. The right answer is 200 feet or how many meters? No?
61 meters.
Okay, 61 meters.
Yes.
Okay.
Yeah. No, I know by meter. But I don't know what feet.
What is the storage tank spacing requirements for multiple class 2 floating and cone roof tanks at a petrochemical plant? In this case, we will use the 8-21 figure 823. 823. 8 8-1. Okay, here. No? So the question is
1.5.
cone and roof tanks for class 2. Here, no? Here. And then at a petrochemical plant. Here, no? Floating and cone roof tanks should be less than 3,000 barrel. So the answer is 0.5 multiply D and A is for class 2, class 3 product. 5 feet spacing is acceptable. Okay. So notes that for class 2 and class 3 product, 5 feet of 1 or 1.5 meter spacing is acceptable. Okay. Let us discuss the chemical processing equipment. Material handling here. We go now. Material handling equipment. Material handling equipment include powered industrial truck and automatic guided vehicle or AGVs, mechanical and pneumatic stock conveying system, and crane. And in Section 8, Chapter 3 of your Fire Protection Handbook, focus on this special equipment. This account for a large number of vehicle fire reported to U.S. local fire department, including large loss of property damage, injury, and even deaths. Let's take a brief look at the basic types of equipment and the system for handling and materials. The fire and explosion hazard inherent to this equipment and some methods of protection. Okay, now let us discuss the AGV, okay, automatic guided vehicle.
Excuse me, I try to close this.
No problem, sir. Lift truck and automatic guided vehicles or AGVs are typical types of material handling equipment. Lift trucks are available in many special designed to suit many use and types of loads to be handled.
لا انت ده مصري. واحد ايه لا فكرت سير.
Chargers, okay. Forklift and squeeze or clamp are the most common type of forklift or lift trucks, and may be electrically propelled or using diesel or gasoline or liquefied petroleum gas or LPG or LP gas or compressed natural gas engine. AGV are electric vehicles that unless recognized by testing laboratory and properly maintained and operated. Lift trucks may introduce serious hazard to the industrial plant. One of that is fire, explosion, container damage, spills and spills or leak of fuel. All vehicles should be selected, outfitted, maintained, and operated according to the hazards of specific environment in which they are operated. Now, if you will go to NFPA 505, the fire safety standard for powered industrial truck, including type designation, areas of use, conversion, maintenance, and operations, lists 18 designation of power industrial truck. So there are 18 types. And this designation letter reflect the power type of material handling equipment. So again, there are 18. CN meaning compressed natural gas. D stands for diesel. E is electric. G is gasoline. And LP is for liquefied petroleum gas. And there are also dual fuel vehicles, meaning the source of power or energy is more than one. Here, hybrid form of vehicle. Additionally, power types, there's something wrong now with the monitor. Huh? I think there's another one. We will use this one. Better, huh? Because it's blinking. Okay. Okay, so let us continue because it's blinking the screen. No? Okay. Additionally, power type are subtype to indicate the level of safeguards for the specific track determined by recognized testing lab. For example, the type ES track is battery powered unit meets the minimal requirements for type E unit and as additional safeguard for electrical system to prevent emission of hazardous sparks and to limit surface temperature.
HDMI.
Okay.
400,000.
So again, for example, an ES track is, there's something wrong guys, sorry ha. In our television here, I don't know what we will use.
Yeah, yes.
Okay, for example, an ES track is battery powered unit, meets minimal requirement for type E unit, has an additional safeguards for electrical system to prevent emission of hazardous sparks and to limit surface temperature. I cannot do anything.
We can use our mobile. If
Mm,
I think correct.
there's something wrong.
Use from out from wallpaper.
Okay.
Use it. Sound right?
The level of safeguarding determine the acceptability of particular track in a specific environment in occupancy. The various type of industrial track are limited to the specific location listed in Table 8.3.1 of your Fire Protection Handbook. Fires and explosion can result. Maybe I have to remove something.
No, okay. Because you use all tie-in of data.
Maybe. Okay. The fire and explosion can result if unapproved truck types are operated in a hazardous location. A potential fire source for gasoline, diesel, CN and LP gas powered truck is fuel leak that are ignited by hot engine, hot muffler, ignition system, or other electrical equipment or other sparks. Again, the danger of ignition is somewhat lower for diesel fuel truck and hydraulic oil. Okay? Because the diesel has higher flash point. We discussed it last time compared to liquefied petroleum gas truck. That vapor are difficult to disperse and tend to gravitate toward lower spots or the pits. The care must be exercised with CN and LP gas to avoid high temperature near oven furnaces and similar heat source. Special safeguards in the design of some types of gasoline, diesel, and LPG gas trucks helps to reduce this fire hazard, but the hazards cannot be completely avoided, and areas of use should be strictly controlled. Okay. Now these are some of the uh, typical example of the like placking or placard, no, or identification. You can also call it marking. Okay, a uniform system of marking has been developed that is actually according to the NFPA standard. And using this track and building marker allow easy and quick recognition of vehicles approved for the type of location. Let's use our fire protection handbook again. Which of this location is considered class 2 division 1 environment? Okay. So you need to go to table A31 of your fire protection handbook. Table A31. Okay. Which of these is not considered class 2 division 1 environment? Here is class 2 division 1. Loading dock, paper, manufacturing, and fiber cordage, textile storage are example of uh, class 2 division 1 environment except for starch or grain processing, because starch,
Yes, grain processing starch.
yeah, that is
Starch
correct.
processing. Yes.
Yeah.
Molding.
So this is table 8.3.1. So next, so what kind of vehicle is approved? We need to go to the same table, 831. I think it is the picture quality, the problem. I just,
It should not fit in.
no, wait. Let me change the resolution of the display. Maybe it's the, let us start. Let us see, huh? So let us see. So what kind of vehicle for this type of facility starts grain processing.
Hello?
If you will go to the
Yes,
table,
sister. Are you downstairs now?
DY and also diesel DY can be use. Okay. So table 8.3.1 indicate for class 2 division 1 environment,
Green glass. Green glass.
diesel type
Green
DY and
glass.
electric type EX are approved vehicle according to the table.
Yeah, too much.
Okay, for fiber and
I'm
cordage,
now.
class 3 division 2 environment, if you will go to the same table, that is fiber and cordage textile.
Actually,
Okay, the type of vehicle it can use
just one piece.
the same table
Where are you right now?
is type E. Type E, type of equipment. So let us discuss the electronic equipment. Computer and other IT equipment are particularly susceptible to fire damage and the accompanying heat, steam, and combustion product. Elevated temperature may even damage IT equipment and the data in them. So electric components and related media can vary in their failure points. According to the test, it is shown that the permanent damage of this equipment and data storage media can begin at temperature above 120 degree Fahrenheit or 49 degrees C and 52 degrees C, magnetic tape, the floppy disk, and similar material start to lose the info. Sustained temperature of 66 to 79 degree damage the hard disk and other equipment components. The presence of high humidity can also be an issue. At 107 degrees C with humid condition, microfilm damage begin. And at 176.5 degree, 149 to 165, it fails at higher temperature and the paper product can be damaged at 176.5 degree. Damage to paper product and major IT component. Finally, between 343 and 399, polystyrene case and real degrade, produce flammable styrene monomer. Further evidence suggests that this vulnerability may be seen in high average loss per fire in electronic equipment room fire, even when they are confined to an object of origin. The Section 8, Chapter 6 of your Fire Protection Handbook provides an info about the need to protect electronic environment. Many systems provide suppression and protection for IT and electronic equipment. Let me change again the display. This one. Maybe okay. Still. Okay. Okay. So let us discuss some of the suppression and protection system. All computer rooms should be equipped with CO2 or Class B and C clean agent extinguisher according to NFPA 10, standard for portable fire extinguisher. The dry chemical extinguisher should not be used. If paper or ordinary combustible are present, sufficient number of Class A pressurized water extinguisher might also be provided. Occupants need to be instructed on how to use those fire suppression system. Another is automatic sprinkler. Few computer room meet the definition of light hazard occupancy Based on the amount of combustible in the room, according with NFPA 13, the standard for the installation of sprinkler system, automatic sprinkler protection should be provided and installed on a hydraulic design basis as wet pipe or pre-action system. Special media and storage arrangements could affect the sprinkler location and necessary discharge density. Any area adjacent to the IT area could cause exposure should also be protected with automatic sprinkler system. According to the report, the U.S. electronic equipment room fire with automatic suppression equipment reduced average loss per fire by 3/4. So meaning, if you have an automatic sprinkler, about 75% of potential fire damages or loss can be avoided. Another is the special extinguishing agent. Sometimes the use of gaseous agent in fire extinguishing system are critical where there is a need to protect data in process, reduce the damage to valuable equipment, or allow for rapid return to full operation. If you provide this kind of special system, the gaseous agent system should be designed according to NFPA 12 if you will use a carbon dioxide extinguishing system. Otherwise, NFPA 2001 for clean agent fire extinguishing system. In the past, many use halon 1301. However, become now more obsolete because of the potential impact to the ozone layer and potential global warming potential. Okay? And we can also consider the NFPA 75 for the standard for fire protection of information technology equipment. Is actually including now the water mist system, if you see on your screen. No? This use a verified water spray, fast acting, reduce both the fire and ambient temperature, may decrease the damage to sensitive data. And water mist system also minimize water damage and environmentally safe. You can go to NFPA 75 for further information. Number 5, other means of protection including the smoke alarm, okay, and a detection device. Smoke detector should be installed at ceiling as well as under raised flooring system and must be designed or installed according to NFPA 72, National Fire Alarm and Signaling Code. And according to the research, about 67% reduction in average fire loss if there is a smoke alarm equipment. The primary purpose of an emergency plan is to prepare key personnel to initiate action in case of emergency. For example, power failure, severe weather condition, tornado, flood, earthquake, and so on. The emergency plan should outline action to evacuate the personnel, safeguard system from further damage, and contain the provision to ensure that backup copy or data info are available in case of damage occur. A prearranged contingency plan should be included to relocate the operation or to provide alternative methods to maintain critical function of organization during and after the emergency. Normally, we call it warm site. No? Alternative IT and other office equipment should be available and either at another office in organization or provided by outside organization to continue operation during restoration of damaged IT equipment and data recovery. Supervisory personnel should develop and regularly review this plan and procedure. And local fire department should be invited to visit the IT and electronic equipment room and become familiar with the emergency plan. So let us have 15 minutes break. So I will try to fix, okay? We have some issue here. So let us have a 15 minutes break. Thank you. So let's go back to our discussion using our fire protection handbook. A fire investigation reveals that the source of ignition was an office machine located adjacent to the IT equipment room. Okay? An automatic sprinkler was not present. If it had been, what would be the average reduction in loss based on existing historical data? We discussed that about 3/4 or 75%, okay, has been the reduced average loss if you will go to page 84 of the handouts. Okay, we just discussed. Where in the fire protection handbook can you find which detection system is best for an IT room with raised floor? Okay, so you can find that in page 8-63 of your fire protection handbook. Okay, this is the statement. A few Halon 1301 extinguishing system remain. The system should be tested and maintained according with NFPA 12A, standard on Halon 1301 fire extinguishing system. Replacement system, also called clean agent, now in the market and are capable of handling fire below the raised floor. Okay? So, why it is more applicable, the clean agent? Because of the potential environmental damage of halons, halon agent. We discussed potential global warming potential and ozone depletion potential. Okay? So the answer is 8-63. Which table in fire protection handbook provide an evidence of flame damage and high civilian injury even when electronic equipment room fire are confined to the object of origin? The answer is you can find a table 8.62, sorry, table 8.6.3, page 8-62 of your fire protection handbook. This one. Okay. So this is the table. Structure fire excluding home originating in electronic equipment room by extent of flame damage. So if you will go back to the question, provide evidence of flame damage and high civilian injury when electronic equipment room fires are confined. That is table 8.6.3. For the evidence of flame damage and high civilian injury per fire in electronic equipment room fire, even when they are confined to the object of origin. Let us discuss now the electronic, refrigerants. Okay, the symbol. There are many types of commercial or industrial refrigeration system designed to provide a means for cooling specific items or location. Many of the principal application of refrigeration include industrial, refining, chemical processes such as controlling vapor pressure of volatile substance during the distillation process, separation or processing, and shifting solubility relationships to permit segregation and removal of undesired constituent such as asphalt or wax and in lubricating oils. In the manufacture, freezing, preservation, and distribution of food products, air conditioning, medicine and drugs, environmental testing chamber, cold treatment of metals, industrial testing, and other miscellaneous application are some of the refrigerant application such as cold storage of flour and fur, for this skin with of animal. The fur means, what's this in Arabic? I don't know.
What in English?
Fur,
For-
Fur. Yeah,
Yeah,
this one.
Yeah.
But normally fur used for animal, like dog, cats. There is a fur, no? And for ice making and used in skating rinks. We are also using that in skating rinks, no? Refrigeration. Now I don't know this city center, no, their skating rink now remove. Now, no more ice now. They are just putting some display something, no. In section 8, chapter 12 of Fire Protection Handbook concerned with common types of refrigerant and their associated hazard. Despite many types of refrigeration system and their wide
For that means farwa.
Farwa?
Farwa. This is of animal of lamb.
yes,
You
yeah.
remove
The one you're
fur from
removing, you are
lamb,
using
and
also.
someone uses this is for
You are using also sometimes make dress,
Yeah.
clothes,
in Arabic farwa.
farwa.
Farwa is lamb. Farwa of lamb.
But farwa can also use in cat,
Cat, dog, yes.
wolf,
Wolf,
tiger, lion.
tiger, lion. All
Okay.
this has fur.
With farwa, ha?
All
Farwa.
of them have.
Okay.
And the human people use this for all
Clothing,
all,
no?
all people.
Clothing.
Yeah.
Yeah, some we still use.
No, was maybe 500 years ago. They use this for to wear.
Yeah.
They use this for as
I think until today.
for clothes. Huh? Until now,
Yeah.
some. But still
Like
not more.
I think in leather jacket, for example.
Yes.
It's not a fur, but still it's
They
skin.
use the book.
Despite many types of refrigeration system and their wide-ranging application, this system differ only in mechanical and thermal design and in the fluid used as a refrigerant. So this we will discuss different type of refrigerant now. All refrigeration system are considered heat exchanger, meaning the system take heat from one space and transfer to another. So like here, there is let's say FCU here. Actually, the evaporator, okay, is actually absorb the heat of the room. So in replace of colder air. On the other hand, if you have an outdoor unit, condensing unit, for example, this is actually heat rejection, meaning it rejects heat to the atmosphere. So that's why evaporator is inside because it's a form of heat absorption, and condensing unit is outside, which is heat rejection. Otherwise, in a colder country,
It's outdoor unit. Yes.
yeah, in a colder country, maybe you're considering revise. What's this? Reverse condensing unit inside. No need. Directly heat exchanger, heater, not heat exchanger. No. To accomplish this transfer, refrigerant fluid are used that will readily absorb, transport, and release the heat under controlled condition. This fluid operate in both liquid and gas. Actually, the refrigerant in a typical refrigeration system, when it enters evaporator, it's actually achieving it's changing its phase from liquid to vapor or gas. When it enters the condensing unit outside, it's become liquid. When a refrigerant in liquid state change to gas, it's absorbed heat from its surrounding in the form of uh, evaporators or superheater or economizer. This is what our term in mechanical. Conversely, when a refrigerant in a gaseous state condenses back to a liquid, it releases heat to the surrounding. And the most effective refrigerant, material that can vaporize and condense at desired temperature and pressure. it might not seem logical to associate the cold and freezing temperature of refrigeration system with fire hazard. But there are few things to consider hazardous in this kind of refrigerant. Some of the fluid used as refrigerant are, you have to know that they are flammable also. Some are also explosive if it is mixed with air, meaning it creates a chemical reaction, make it become explosive with mixture with air. And other refrigerants are also considered toxic, as what you can see on the screen, meaning they escape during fire, can cause injury or death or interfere with firefighting operation also. And here we have identified numerical designation based on ANSI or ASHRAE 34. This is number designation and safety classification of refrigerant. Normally, the number can up to 4 digit, with each number represent to chemical makeup and multiple components that comprise refrigerant blend. A large table of this classification is available in section 8 also of your fire protection handbook. So if you see there is a safety group, and this safety group is this table. So if you see, okay, there is an alphanumeric character with the capital letter indicating toxicity and the number indicate flammability. So A, B is toxic level. No? B has a more toxic level. And flammability, meaning 3 is more flammable than 1. Okay? For example, A1 will have the lowest flammability and toxicity. So if you will go to this, R410, R32, it's a combination of R32, 50%, and R125. That is A1. And R22, chlorodefluoromethane. No? And next, while B3 would have the highest level in both category, such as your, not here, I think the ammonium is very hazardous. I think it is B3. No? Let us see. Understanding this refrigerant safety is valuable for contractor installing the system, facility owner and manager, and even the consumer using refrigeration device. But it is specifically important for the fire protection professional. For example, if A3 refrigerant is being used in a new facility, caution should be taken to ensure that there are no ignition source nearby, that there are no leaks. Some refrigerant blends such as R22 have potential for flammability when mixed with air. So here, chloro-difluoromethane, R22, is actually probably has low toxic and flammability level. However, it is very hazardous when it is exposed to air, enriched with oxygen in some condition. Even though, as what we discussed again, this is a safety group A1. Now, along with this, I also gave you some study of ASHRAE A3 refrigerants, which I already provided. If you want to see further details of that, you can read that. In the search for more environmentally preferable refrigerant, if you see our ice, South and North Pole ice caps are now melting because of these greenhouse gases, no? We are searching now for more environmentally friendly refrigerant and move away from the use of chlorofluorocarbon or CFC. Many of these substances are serving as interim measure used until the phase out of ozone depleting and global warming refrigerants meet the target of U.S. Clean Air Act. Okay. Actually, CFC, I think one of that is the R11. I think it has already an obsolete type of refrigerant. But however, in some third world country, still they are using probably this kind of refrigerant. The journey toward compliance caused the refrigeration and HVAC equipment and appliance to revisit the use of substance that have good environmental and thermodynamic property, such as refrigerant, but which are also sometimes flammable. This switch to flammable refrigerants mean there's a greater potential hazard near this system. And as what we discussed, refrigeration system contains circulating refrigerant fluid. They also consist of condenser and receiver, control device, evaporator, and compression device. Refrigeration system are classified into two ways: by means of compression system, mechanical absorption, or steam jet, or the method of cooling, direct or indirect. Each configuration has its own set of hazard to consider. Let us discuss the system types and hazards of mechanical refrigeration system. So this is the common, very simple schematic diagram. No? There is a compressor, evaporator, throttling device, or expansion valve, we call it like that, and condenser. And this is just actually what we call the refrigeration cycle. In this system, the compression is achieved by mechanical either reciprocating or centrifugal or rotary screw type of compressor. And refrigerant can include any of the fluids shown in table 8.12.1 of the Fire Protection Handbooks. The absorption system is mechanically the simplest and common use today, and the oldest known for producing refrigeration effect. And this type of system contains basic refrigeration component. There is an absorber, heat exchanger, and generator system serving as the compression step. The absorption cycle uses an absorbent as secondary fluid to absorb primary fluid, which is gaseous refrigerant that has been vaporized in the evaporator. The evaporation process absorbs heat, which provides refrigeration. The two most common fluid are water, lithium, bromide, and ammonia water. The water lithium bromide is used primarily for air conditioning application, and ammonia is used for large tonnage industrial application. So in the manufacturing processing plant, industrial plant, normally this ammonium type of heat absorption, it's a refrigerant, yes, R717. Sorry, R718. Temperature for process cooling. In one system, water is refrigerant and the other is absorbent. And steam jet. We also call it steam vacuum or steam ejector, and normally already used for 100 years. No? It is least common refrigeration cycle used today, but there are units that remain in use for air conditioning and process cooling in industrial plant such as pulp and paper, petrochemical, food processing, and pharmaceutical. So let's check in our knowledge. You are a manager at local movie theater. There is a new construction occurring in a portion of your theater, and the HVAC installer needs to solder something as part of installation. Solder is like piping, pipe. Let's say copper pipe. We will we will put the filament device, filament. So in the spaces, so in order to avoid the leak. It is not welding because welding is fusion of two metals. Soldering is, filling the gaps between the pipes so it will avoid the leak. But still, it is a hot work, considered hot work, no? If there is an A1 refrigerant leak, so meaning that jointing system that they're using is for refrigerant, no? And the area of leak is a standard temperature and pressure. What does it mean? A1 refrigerant leak. We discussed, no? Low flammability, and low toxic, no? A1. So in the table, safety rating means it has no flame spread or flame propagation. In the same scenario, what would it mean? The refrigerant used was R50. So we can use the table 8.12.1. We need to use 8.12.1. R50. Here. Methane, no? CH4. This one, A3. Meaning, flammability low, toxicity is high. So, flammability is okay. So let me go back now. I confused. So the designation A or B, toxic, and letter flammability, no? Number flammability. Now it is A3, meaning low toxic but high flammable. And 3 means probably dangerous, no? It might cause explosion hazard, no? Correct? You are the manager of strip mall. A new food court is being built and you are overseeing the installation of large room refrigeration system. If R134 is used as refrigerant, what class or safety group it will be? So same, R134A. R134A we are using in car, in our car, no? Available all in the car mechanic, no? Tetrafluoroethane, no? So the answer is A1. Mm. No flame propagation and standard temperature and pressure. Correct. That's why we are always using this for car refrigeration system. Very effective. Sorry, ammonia. As what we discussed, this is probably B3, no? 117. R717. B2. B2. B2 means
They're toxic, medium toxic, and low.
no, B means toxic, no? It's high toxic. A is low toxic.
Yes.
And flammability probably medium or low, no? But there's no medium here. So our answer is high toxic and low flammability. Class 2 refrigerant. Are you sure this R17 is, yeah, it's B2 designation. No? Again, very important for us to know the designation. No? So we will know if we need a hot, if we need to keep away from hot work area or not. If we need to wear some extra protection like PPE or not. No? Let us discuss semiconductor manufacturing. And Section 9, Chapter 9 of Protection discuss semiconductor manufacturing. It is also known as integrated circuits or chips, meaning there are extremely small circuit pattern. And there are a number of NFPA codes and standard for semiconductor equipment and materials international, SEMI. No? And NFPA 318 is the standard for the protection of semiconductor fabrication facility, applies to any semiconductor facility, contains clean room or clean zone, provide set of reasonable requirement to protect such facility from fire or related hazard. NFPA 1, Fire Code, and NFPA 5000, Building Construction Safety Code, support NFPA 318 by further addressing hazardous material storage, use, and handling, fabrication area, and separation wall, energy power requirements, and hazardous chemical gas room separation wall. Okay. There is a term SEMI or SEMI. No? It is meaning, the meaning is Semiconductor Equipment and Materials International. And this organization provide guideline such as SEMI S14, no? Safety guideline for fire risk assessment and mitigation for semiconductor manufacturing equipment. Applies to all types of semiconductor manufacturing equipment in the fabrication and sub-fabrication area, assist the makers and user of semiconductor manufacturing equipment, assessing and mitigating fire and combustion risk to equipment and product. There is also SEMI S2, meaning for Environmental Health and Safety Guideline for Semiconductor Manufacturing Equipment. And it provides performance-based environmental health and safety consideration for semiconductor manufacturing equipment. And there is an extensive fire protection content as well as the guideline for risk assessment and risk reduction. So this is just to be familiar. In a clean room, in a clean zone, it is you can use NFPA 1, NFPA 5000. Another one is the NFPA 318 and the semi-standard, no? Semiconductor Equipment and Material International. One is S14 and the other is S2. Potential fire hazard for semiconductor manufacturing are common to other manufacturing industry, such as flammable liquid and gas. There are, however, other hazards not widely encountered in other fields, such as pyrophoric gas, toxic material, radio frequency field, and ionizing radiation. The certain chemical with purity constraint require special handling techniques also present potential hazard. And another standard for that, NFPA 30, Flammable and Combustible Liquid Code 2018. A number of fairly common flammable liquids are used in chip fabrication. Storage and handling of flammable liquid should generally follow principle of NFPA 30, Flammable and Combustible Liquid Code. Special precautions are necessary to handle flammable material safely. These include carts designed specifically to transport containers safely from the flammable liquid storage room to the clean room. These carts hold the container firmly upright and can even contain the contents in the event of leakage. Bulk dispensing is also common throughout industry. The flammable liquid is stored in a closed dual-contained system piped into the process equipment. Appropriate safeguard must be taken to ensure stability of the pipe system. Flammable and pyrophoric gas, flammable gas used in industry can be pure or they can be mixed with hydrogen or nitrogen. The other gas used in semiconductor manufacturing are pyrophoric, meaning they ignite spontaneously on contact with air. This is the problem with pyrophoric gas. If there is a contact with air, it ignites spontaneously. And pyrophoric and toxic gas should be stored outside the plant and piped to the clean room in a welded stainless steel tube. Process equipment using high concentration of pyrophoric gas should contain exhaust system
So sorry for this.
with continuous monitoring device to warn abnormal condition. Studies conducted on silane pyrophoric gas resulted in CGA publication P32 2000 Safe Storage and Handling of Silane and Silane Mixture. And this standard actually helped to establish the minimum separation distance for pyrophoric system installation. And the NFPA 318 contained the standard for the protection of semiconductor fabrication facility. Health hazards are also present in semiconductor manufacturing. Several gas used in semiconductor are highly toxic. The toxicity hazard must be monitored continually and must be controlled. In addition to the piping and control system, the exhaust system should include air treatment process for this material and to avoid release into the atmosphere. You know, I've also before I have a project in a clean room, and there are chemical piping going to the equipment in a semiconductor area. In the trench, if there is a leak, we are installing, what's this? Leak detection system. So it will trigger an alarm if there is a spillage or leakage of the chemical. But when we install the chemical pipe going to the equipment, it is double containment. You got my point? If there's a leak on the pipe, it will still not leak. Why? Because there is another containment. And we are using a special type of tube. We call it tube. It's coming from US also without joint. So normally in the piping system, we will introduce a joint, right? But when I remember the chemical piping system, we use a pipe without any joint at all. No joint. So if it needs 100 meter, no joint. The double containment, of course, we just properly sealed. So not only that, some gases, I think hydrogen gas, we use stainless steel. What's this? Stainless steel pipe, and we are using special type of welding, TIG weld. you know, TIG weld normally used in a handrail, no? Normally, you have a meeting, sir?
Training.
Yes, sir.
Schedule is also the other guy.
And in Egypt, yes.
Yes, sir.
ده معاهم
So we call it double containment, no? In case there's some spillage, still, but it's good that there's a double containment and you also have this strip that detects also the leak. Very sensitive, this kind of room, and imagine if you will go inside the room, you need to wear this kind of PPE, and because the clean room is very sensitive to any kind of dust, even small powder. If you are a worker there,
PPE.
yeah, actually we call it not PPE. It's yeah, probably this person is wearing a PPE,
Yes.
the gloves and the face shield.
Yes.
But the overall, we call it bunny suit, and you're supposed to have a shoe cover. Even very small particle might destroy the chips or the this small circuitry.
Yes.
So that's why before you enter this one, there is also an air shower station.
It's danger for body.
No.
Any
It's
chemicals?
danger. No. This clean room is very sensitive. It's a manufacturing plant, basically.
Unsafe for safety.
For normally for the electronics, like this semiconductor, no?
Yeah.
Making laptop. But it's very sensitive to dust. So even, maybe let's say this worker,
Our life,
not allowed to wear any makeup, any powder, because it's contaminate the
no.
working facility.
Yes, our life now. In the future, maybe we will use this alloys.
Hmm?
Did you get my point? Maybe we will use this face shield and face mask and wear clothes, always, because of corona and the next virus. New virus in the future.
As long as
You get my
as
point?
long as the vaccines, I think it's already been scattered and
Vaccines?
everyone is vaccinated.
No, vaccinate for 6 months only. After 6 months, you will vaccine again. You will take again vaccine. I get it. After 6 months, we will get more vaccine. 6 months, we are not live without vaccine.
Correct. But I think ivermectin, if you heard this medicine, many research also suggests that this is very effective to fight the COVID-19. Just one tablet every 3 weeks, ivermectin.
Ivermectin every 3 weeks.
This is over the counter, sir, and there's no side effect if you will use that. This is used for body parasite, including your lice to your hair. If you have some lice and you have some maybe worm in your stomach, probably it will. Yeah, this is used for that. But now there is a study. You can use that one also for to fight COVID-19.
What?
Tablet, one tablet every 3 weeks.
New tablet?
No, this is 40 years ago. 3.5 billion already used that. There's no side effect. And it is over-the-counter medicine in the Philippines. I don't know here. So if you have a chance, you can just take that. No? Or even if you have already a COVID symptom or already infected by COVID, just take one medicine and that's it. It's okay. Just one ivermectin. Anyway, it's still the further research is required, but it shows, promising result and already endorsed by many doctors in UK and in US. Check it out. So what are the hazards apart from the chemical hazards? Radio frequency hazard, energy and exposure to UV radiation also is problem. And if you are a personnel working in this kind of facility, you're supposed to make the people well trained. No, let's check in your knowledge. Which of the following specifically provide the safety guideline for fire risk assessment and mitigation for semiconductor manufacturing equipment? We discussed, no, it's either S2 or S14, but the answer is S14. That is a safety guideline for fire risk assessment and mitigation for semiconductor manufacturing equipment. And which of these is repeatedly mentioned as a key safeguard for this environment? So the key, in order to minimize or dilute the concentration of this kind of hazardous chemical, toxic, fume, dust, is a proper ventilation or exhaust system. So it will reduce the concentration, avoid toxic and flammability combustion. No? Let us discuss energy and solar storage or ESS. And before that, the diets and what's on fire the demonstrate challenge that the solar panel and energy storage system present in firefighting. We know that solar, now I think the use of solar panel is become very common, but there are also hazards associated with this. And let us watch a video. No?
The Dietz and Watson fire demonstrates the challenge that solar panels and energy storage systems present in firefighting. While the FPH does not address this specialty equipment, processes, and facilities, it is important for the fire protection professional to know about this burgeoning technology.
On 1 p.m. Sunday, for the 40 fire companies and 200 firefighters working to beat down the fire, there were challenges. Water, hydrants from surrounding communities, and a creek have been sources, but tankers brought in more. Solar panels. At first, only the insulation in the roof was on fire, but those energized panels kept firefighters from getting on the top of the building.
If we had a flat roof with nothing on top, we could have got up, trenched it. It's common practice, but with all that power and that energy up there, I can't jeopardize a guy's life for that.
Because it is connected to a battery, which is, this is not the solar panel, it's probably not the Sardos, but the connected UPS or backup power. No? So tremendous growth has been taken, as what we discussed, with the use of energy storage system or ESS, using technology in thermal energy such as solar or photovoltaic power, and electrochemical energy such as lithium-ion battery. This is what's make it difficult for the firefighter to contain or suppress the fire. Solar panels are found on all manner of public and private structure, and installation of white industrial battery energy storage system, BESS, are becoming common across the globe. Utility business and even mainly consumers are grasping technology potential to help control energy costs, increase efficiency at the same time. And BESS, battery energy storage system, are tucked in office park, subdivision, apartment, parking garage, rooftop, strip malls, and various working sites as well. So meaning the application is very widely. Stored energy can be used in a variety of applications, from electric grid, power station, and home, to powering electronic and transportation such as battery-powered and hybrid electric car. While this new technology is very attractive because it is environmental friendly, it is not without risk. The expansion of this system in thousands of ESS across the country where people live and work creates an increased potential hazards to life and property. At the same time, identifying the associated risks and how to deal with them has been significant focus for NFPA and other safety and research organizations. The published requirement for ESS in NFPA 1, Fire Code, and NFPA 70, National Electrical Code, and authorities having jurisdiction have some requirements for the protection and prevention for this system. However, due to the complexity of the system, a new standard has been developed to address the fire and life safety concerns associated with them. And here you go, there is a development of the new standard, NFPA 555, the standard for installation of stationary energy storage system, includes guidance for range of battery and chemistry type on installation, ventilation, maintenance, operation, and retirement of such system. And let us watch a video from Mr. Bruce Clark discussing about the photovoltaic and ESS.
During the loss prevention surveys, one of the other areas that we look at, and this is why our risk engineers are constantly going through training and having to stay up on current codes, is energy systems. NFPA 110 and 111 cover standby energy systems and emergency generator systems, but there's a lot more risk out there these days, and there's a lot more, and risk's always evolving. For example, photovoltaic systems or PV systems or solar panels on roofs. We're seeing fires in these. There's a new, and energy storage systems is a brand new type of system being installed in quite a few facilities. There's a new NFPA document on that, NFPA 855 coming out. So as part of being risk engineers, we have to be up to date on the most current fire protection systems and risks that are out there. And power, energy, electrical systems is one of those areas that is currently in change.
Another video transcript for the mitigation or minimizing the potential hazard related to emergency response.
Structure fire, 701 Ocean Street.
The best way to approach any incident is by using an organized process to identify and mitigate hazards. We recommend the following procedure: identify, shut down, and watch out. First, identify the location and type of battery energy storage system as part of your continued size-up. Referencing pre-plans can assist in this process. Look for labels and signs on doors and/or electrical panels. Some labels may be generic, like a caution high voltage sign. Others may be more specific and identify a room as a battery room or identify the main battery disconnect switch. Look for SDSs that may be placed nearby the batteries. Reference these sheets to identify specific battery chemistry. After identifying the presence of a BESS, determine the level of power that must be shut down or secured in the structure based on the severity of the incident. For example, a fire alarm activation in a building with no smoke conditions present may not necessitate disabling the system. However, a response to a fire in a building that would normally require securing the power to the entire structure would also require the disabling of the BESS. Watch out for remaining hazards. One of the things to be aware of is the concept of stranded energy. This simply means that even after the disconnects are thrown, the batteries themselves retain their charge. For this reason, you must be sure to use caution working around these batteries even after shutdown. Some batteries are connected by open bus bars and have exposed battery terminals. Unintentional contact with these by firefighting personnel could lead to a shock. If there was a fire involving the BESS, continued monitoring for reignition is imperative. Studies have shown that this can take hours or even days to occur. In certain circumstances, a thermal imaging camera can be a helpful tool in the continuous monitoring for temperature changes.
Other items to watch out for in the event of a BESS fire are air quality and ventilation. Responders should conduct a gas sampling to measure oxygen levels and monitor the area for flammable or toxic gases. Keep in mind that activation of any inert gas suppression system will create decreased oxygen levels in the area. It will also be important to continue to operate ventilation systems and use portable fans as necessary. Before releasing the scene as safe for occupants to return, the incident commander should verify with the battery manufacturer or qualified system specialist that the BESS does not continue to pose a hazard. For additional energy storage system safety training, check the NFPA website.
Before releasing the scene as safe for occupants to return, the incident commander should verify with the battery manufacturer or qualified system specialist that the BESS does not continue to pose a hazard. Okay, so let us see the BESS emergency response steps in the correct sequence. And Okay, so what is the first one? Check out for SDS, no? Safety data sheet, and pre-plan, identify the type of ESSS involved. Another is a shutdown, small breaker. This is the video what we presented, no? Before the main breaker and turn off the main battery disconnect. Another steps, the next steps will be watch out for remaining hazards like stranded energy and open busbar. Busbar may also electrocute, no? Maintain a prolonged monitoring period for temperature and quality level. You can also use this thermal imaging equipment or device and verify with the manufacturer or qualified system specialist that the scene is safe for occupant return. Let's check our knowledge. Again, using the fire protection handbook. You have been called on the scene to investigate a semiconductor facility where fire broke about 1:30 in the afternoon on a Sunday and continued to blaze well in the next day. Apply what you have learned throughout this module to your fire investigation. While you're walking around, you notice that what appears to be some welding equipment severely damaged from the fire near the hazardous area. How far should open flame be from the hazardous area? Select the correct answer, but the answer we will get it from page 8-22 of your fire protection handbook. Page 8-22.
No 22?
There is.
Twenty-one, 32.
I don't know why page 8-22 didn't do that. This one I have to do. Anyway, there is a fire protection handbook. No?
So is not allowed. Correct?
Hmm?
Hard copy only.
Yeah. Okay. As recommended, open flame should be kept at least 100 feet from any hazardous area.
30.5.
Okay. So we'll go back to the question. So the answer is 100 feet. Open flame should be at least 30 meters from a hazardous area. As you continue to walk through, you notice an enclosed conveyor belt equipped with automatic sprinkler. Your initial observation indicate that the fire had traveled an excessive distance along the belt. What safety feature must you check to verify that it was functional should sprinkler activation occur? Page 8-36. Okay. So here, important fire protection consideration are around conveyor, include location, housekeeping, temperature, dust, and material being conveyed. For belt conveyors, both the belt's combustibility and material being conveyed must be considered that it can contribute to fire and spread. Okay. So here, when conveyors are designed and installed, protecting openings and controlled static charge must be given careful attention. So now, what safety feature must you check to verify that it was functional should sprinkler activation occur? What safety feature must you check to verify that it was functional should the sprinkler activation
B.
occur? No?
No, not B.
So how you will know?
Reverse. Belt reverse. Not reverse.
So actually you need to, how to prevent, the hazard is accumulating, if you remember last time, because of the dust accumulation as the conveyor moving. But in order to stop or prevent the accumulation of the dust, which is cloud dust that is explosive, the system should stop. Not reverse, meaning reverse, the conveyor should run in reverse, which we still so the the conveyor should stop.
C.
You make your way to the IT room and notice major components has failed. What does this tell you about temperature of fire event? Okay, we discussed it earlier. No, major IT components will fail at which temperature? The maximum one, no, 300 degree or 149 degree. I think you're outside when we are discussing that, but it is in the page 8-61 of our fire protection handbook also. The refrigeration unit is located in the cafeteria and kitchen area. You came to learn that the refrigeration unit had leaked and the refrigerant classification was R143A. What are the flammable limits by volume in air? So we need to use the table, no?
4.5.
Lower flammable limits. 7. And the upper 19. That is the flammable limits by volume of air.
C.
C. Okay. As you prepare to head out, you check the clean room to consider if anything could have contributed to the fire. What hazards are unique to the clean room? As what we discussed earlier, radio frequency field, pyrophoric gas, and ionizing radiation are some of the potential. Clean room will never have this dust. This is what we're trying to prevent. That's why we call it clean room, meaning almost zero dust. Okay. And we have completed the module. And now we will be having a quiz. Let now you open your cell phone. Okay. And there are, I think, 16 questions. Okay. I'll give you maybe 16 questions. I think 25 minutes, because it's too. Because in your actual exam, one question, 3 minutes.
How many questions?
100.
100 and should back
70. Let me check if it's already shared, the quiz. Not yet. Not yet. Huh? Let me share now. Huh? Let me share the module.
It's not here, huh?
Yeah, I didn't share. I think I have here.
Why you don't do it? How many reviews are there? 15?
Hmm?
15 reviews or 16? I think 15.
Okay, so you can start answering now.
Where is the link? You will send?
Yeah, I sent to the WhatsApp group, and I will also share it to the chat box. Okay. How many minutes you want? How many questions? So 16. I think make it 30 minutes. Huh?
Okay.
Hmm? Yeah, too much question. Good luck.
This is module 13. Huh?
Module 9.
Green, green. 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 Green.
The time is up. So now let us answer the right answer. Determine the right answer now. At oil plant, which of these requires the most intra-unit spatial separation from rundown tanks? Anyway, only two got provided the response. The answer is D. The spacing requirements are same. Class 2 division, Class 2 Division 1 location, which of these fuel are approved? DY. Table A31. At petrochemical plant, what is storage tank spacing requirement? Figure 823. D, 2 times D, 200 feet minimum. Number 4, A bakery. Used for GLP and GCN trucks. Table 831. Number 5, which table in fire protection handbook show neutral flame temperature? Table 9.6.1. So let me show you. Yeah. No? Flame temperature of fuel gas. Yeah. Number 6, there are no intra-unit spacing requirements for all, but which of this combination? Between motor center and cooling tower. 8-19. Motor center and cooling tower. No, there is 50. Okay. So here, all, let's say this one, no, nothing. Between service building and motor control center. Motor center and service building. Oh, see, nothing. No spacing requirement. Only this has a spacing requirements which needs 50 feet. So answer is B. Petrochemical plant. What is the storage tank spacing requirement between class 2 chrome group and class 3 chondro rack? Figure page 8-1. Answer is A. 0.5 by what class? Class 3. Here. Cone roof tank, class 2, class 3. Greater than 10,000, less than, see, this one. 0.5 multiplied by D. Because fiber plastic dust are typically present in semiconductor fabrication, which of these are specifically designed? We discuss, this is the page 144 of your handouts, your workstation. Number 9, in response to growing use of BESS, this is page 158 of the handouts, NEPA 855. Number 10, information technology fire protection system must take into account many factors including, so in IT, the problem there is temperature, no? because it's damaged the property. So B, okay? Which of these? Okay, so we discussed page 140. Semi S2. A. Number 12, we discussed also this in page 143 of the handouts. We discussed that silane, dichlorosilane, this kind of pyrophoric gas, once it is exposed with air, it is simultaneously ignite, make it combustible. No? For example, your R22, no? This has no acid, but when it's exposed to air, it's become combustible. In response to the growing use of BESS, photovoltaic and other ESS technology, new standard, NEPA 855. This is new. Special precaution is necessary to handle flammable liquid in semiconductor manufacturing. This is discussed in page 9-126, special card. Too much, ah. Which of this type of refrigeration system used in large industrial application involves refrigerant mixture that present fire, explosion, toxicity, and contamination, absorption system, especially the ammonia. No? Which of the following are true about move from chlorofluorocarbon, CFC, which has a high ozone depletion potential and global warming potential? Okay? All answer B, C, D. Alternatives of less ozone depletion are good for environment like R134A, no? And alternatives have less global warming potential. We discussed GWP, global warming potential, and uh, ODP, ozone depletion potential, which is the reason why the CFC, chlorofluorocarbon, are banned. Actually, it was a treaty signed in 1994, Montreal Protocol. Okay, so in Canada, it was a sign of many countries. So that's all for today, and I hope you.
I get 10.
You cannot see what you're sharing, huh? Sorry. What I'll do, I will share the answer, no, the instructor material. So don't worry about that. Okay, including the handouts, because in the handouts I removed the answers. So I'll share you now also the handouts for the instructor version of handouts, and instructor version also of this with answer. Okay, so you can review alone. Okay, so thank you and see you this coming Thursday.